So my name is F BEKKAOUI. I did my PhD in France. I did some of the work at GFC Rivet with Professor Migignac in plant physiology, and then went to Canada for a big chunk of my career in Saskatchewan, where I worked on canola and later on wheat. And then came back to Morocco, worked with INRA as director until December. So I'm not anymore the director of INRA, but I continue working with them and with the Ministry of Agriculture. So I'm pleased to share with you some of the research results, most at INRA. So in my second part of my life, I've been more a manager than a scientist. So what I'm going to share with you are results of my colleagues rather than my own. So I'll just start with showing the importance of agriculture in Morocco, talk about some of the impact of climate change on productivity, talk about the strategy of Morocco in agriculture called Generation Green, and some example of research activity where INRA has been working on to address the impact of climate change, and end up with some of the information on genetic resources, what Morocco is doing in this area. Agriculture in Morocco is vital to the economy. It contributes about 12% of GDP, and most importantly, about 40% of the population is involved in agriculture. It's also an important export. 60% of Morocco's product end up in Europe. In terms of land, there's approximately 9 million hectares, and mostly rain-fed, with 1 million irrigated, approximately 1 million irrigated. There are also, for irrigation, about 150 dams with a capacity of 19 billion cubic meters. Currently, they are at 37% full. We went through almost 6 years of drought, and the level was close to 20%. Fortunately, March, this last month, has been very, very rainy in Morocco, and we recovered quite a bit of that in terms of storage in dams. Some of the key products, citrus, olive, tomatoes, potatoes, barley, and wheat. Now, one of the things about Morocco is the change in ecosystems. If we go from north to south, we go almost from 1,000 millimeters of rainfall in Tangiers, let's say, to less than 50 millimeters in southern Morocco, in Dakhla, for example, in the desert. And that's a challenge in terms of research, because that means we have to address different ecosystems. So INRA has 10 research stations, and each station is about focus on a specific area, going from doing work on wheat to work on date palm, to work on some mountainous region crops, etc. Now, to show the importance of the impact of climate change, I'm going to start with an example of cereal production. Cereals, wheat in particular, is an important staple in Morocco. Moroccans eat a lot of bread, and Morocco doesn't produce enough wheat, mostly when there is not enough rain. 4 million hectares is about grown to cereals, and when there is not enough rain, then we have to rely on imports. And I'm showing 2 years, one after the others, where in 2021, there was about 300 millimeters of rainfall, and we produce about 100 million quintals, which is almost sufficient to feed Morocco and produce enough bread. The following year, less than 200 millimeters, we went from 100 to about 30 million quintals, which is a 70% reduction in production. And that shows the impact of low rainfall. It's not a single point. In fact, one of my colleagues have been looking at drought years since the 1900s, and we can see the impact. We are living climate change. If we can believe in this figure, And if we look at these years by quarter centuries, between 1900 and 1975, there was about 4 years of drought in a quarter century on 25 years. And since 1975, the frequency of drought years have doubled. We consider a drought year when there is 250 millimeters rainfall or less. The temperature has been increasing on average 0.04 degrees per year. And the last several years, if we look at the temperature, the deviation on temperature compared to the average, we've been having almost 1 degree more heat since 2010 compared to the average. This figure shows a history of cereal production. So cereals meaning bread wheat, durum wheat, and barley. This line in here, this line here shows the number of millions of quintals and the rainfall, and there's very good correlation with the rainfall and productivity. The green histograms or lines show good years when there was about 600 millimeters of rainfall with almost 100 million quintals of production, and the red lines where we had about 200 millimeters, and there we had less than 35 million quintals on wheat production or cereal production. So Morocco has gone through different strategies to address food security and productivity. Between 2008 and 2020, there was a strategy called Morocco Green Plan. And since 2020, we have a new strategy called Generation Green. The difference between the two strategies, the first one focused significantly on high value crops and irrigation. The second, and this strategy focused mostly on the human impact. So there are two pillars. The one shown in red is focusing on the human element, where we are trying to increase the household income of 400,000 farmers, trying to get them from a lower class income to a middle class income, having at least a minimum wage. The other example is to form new farmers and entrepreneurs and train more new people in agriculture. Also increasing the contribution of professional agriculture organization in farming, and also introduce new digital tools such as using services, e-services with 2 million farmers and hiring more agricultural advisors. So that's the human or the pillar. The other pillar is focusing on a sustainability of agricultural development. And there are 4 axes. One focusing on consolidation of agricultural value chains. Second, on modern and efficient distribution channel. A channel on or an axe on quality, innovation, and green tech. And the last one on resilient and eco-efficient agriculture. And that's where my talk will be mostly focused. What research is doing in this area. We divide the orientation of our work or INRA and other research institutions in 9 objectives. So we're trying to improve yield by 50%. For instance, the average yield of cereals in the 2020 was approximately 2 tons per hectare. By 2030, we try to go to 3 tons per hectare. If we get to that average, we will get closer to self-sufficiency in cereals. We'll be developing new varieties, more resilient, more resistant to disease, valorization of agricultural product. A lot of product in Morocco are produced and exported in their raw form, about 20-30%. We like to go to 70%. In terms of organic farming in Morocco right now, there's less than 20,000 hectares of organic farming. I'd like to go about 100,000 by 2030. A diffusion of innovation, a lot of results in research don't get to the farmer or not in a reasonable time. So we want to improve that diffusion of innovation, promotion of agriculture in fragile areas. So those are like the very arid zones, the mountain zones, the oasis. There are a lot of challenges we would like to improve and promote those areas. Development of digital agriculture is another sector that Morocco is putting more emphasis on. Water efficacy improvement, that's one of the key issues. We would like to double the efficiency. In other words, do with 1 cubic meter, do generate or have a double the yield compared to what we're doing with now. And finally, soil conservation. Due to monoculture in some areas, also challenges with drought and other factors, soil has impoverished in organic matter, and we have a strategy to do 1 million hectares of direct seeding, and I'll talk about that later. So I'm going to try to give some example of some of the research results that we are obtaining or activities we're undertaking in NR. What I highlighted in red are objectives that are dealing with resiliency and productivity. The aspects that are impacted yet, of course, are the nexus, soil, water, biodiversity, and there are 3 factors important. We cannot separate one from the other. And again, I'll give some example when it comes to these factors and what we are doing. Well, Morocco, given the fact that we've been going through drought years and a lack of rain, has initiated different activity and put a lot of emphasis in terms of saving water and storing more water by building new dam. We started new activity in terms of reusing water. In the city of Rabat, for instance, all the gardens are irrigated with reused water, and we are going to generalize that to other cities. Another example of making the water more available to the south is by building channels of water going from north to south. There is excess water in some areas in the north, not enough in the south. So there are some canals that are being built. Desalinization is an important objective. There's already 2-3 plants working now, and there's 6 or 7 being built right now in terms of desalinization. And some of that desalinated water is going to the cities for consumption, human consumption, and some of it is going to agriculture. Water harvesting is another objective that we set up. There are some other areas where we are working on to improve water usage, precision agriculture. We have project on intelligent irrigation system, using satellite images to follow the availability of water. Agroforestry is another objective or area we started working on, and we are going to develop more projects on that. And vocation card, I show an example of that. We have also to be very sensitive to what crops we would be growing. The water requirement varies a lot, as shown in this table, among species. A lot of them are grown in Morocco, and we have to be very, very sensitive to this amount. The requirement for some crops can vary depending on the rain. For example, for barley, even though in the table we show that the requirement is 450 millimeters per year, we can have a reasonable production with 250 millimeters if the water or the rain came at the right time. Temperature, of course, also is another factor, and some crops cannot withstand very high temperature. barley can withstand a temperature of 50 degrees, where the wheat can have its yield affected at a temperature of 35 or more. Vocation card is one of the projects that INRA has been working on and has developed about 7.5 million hectares of these cards. What basically we do is based on historical culture of crops, based on rainfall, we identify specific crops that are adapted to a specific region, and that helped the farmer not grow the wrong crop in some areas. An example we talk a lot about in Morocco, and mostly in social media, is the growth of avocados. And there are some farmers that have been growing avocados in areas where we should not, because there is not sufficient water. They use wells to do that. So INRA has tried to develop these cards to recommend basically the crops to grow in a specific area. We can look at adaptation activities to climate change in terms of water efficiency at the plant level. So we can use agronomy with different practices for that, or we can look at genetics, genetics within the crop level. Here we choose specific species for production, or within a species, and I will give an example for these later. We are also working on what's called deficit irrigation. So here, for instance, a lot of farmers irrigate because they have water available. They look at what the neighbor is doing, and they just put the water based on what they've done in the past or what others are doing. So what INRA has done is taken an example of 3 species: olive, date palm, and citrus, and try to reduce the water that's being used in irrigation, and shown that most of the time we can reduce the amount of water by 30% without affecting the yield. Another area we are working on is what we call complementary irrigation. For cereal, for instance, if there is underground water, even in a semi-arid area, we could maybe use irrigation, but not full irrigation. What we are promoting is irrigation with limited amount of water if it does not rain. For instance, we've shown by providing 10 to 15 millimeters of water or irrigation at the right time can really stabilize the yield and produce enough crops. There are other areas that INRA is working on. Won't have time to go into each of the details, but are shown partial root desiccation, nano irrigation, using hydrogels. We've shown that they can also help in saving water. We have shown also that some mycorrhiza symbiosis can help in terms of saving water, and low pressure drip irrigation, a project with MIT that also shown that we can save water. The choice of crops is becoming really important, and here I highlighted some of the 3 categories of crops or trees that have different needs or different water requirements. The one in green are the one we are focusing on a lot now. Cactus is one of the crops or plants that require the least water, can survive at on average at 150 millimeters and produce crops. Argan is another tree that's very drought tolerant. Caroub, there's a important demand in the fruit of caroub. It's native to Morocco, and we have there's a program to plant 100,000 hectares of caroub because of its low requirement in water. And capers. Morocco is one of the largest exporters of capers, even though it's not consumed a lot in Morocco. There's a big demand, and it does not require a lot of water. Other crops, olive is in the middle. Olive does require some water, and this last year's 6 years of drought we found that even olives cannot withstand the drought. And some people are taking out the olive tree because there's not enough water for irrigation. Fig almonds are examples of trees that do not require a lot of water and can be adopted in some areas. Pomegranate and date palm, on the other hand, are more water. They need more water. Date palm, a lot of people think because it's a desert plant, doesn't require water, but in fact it does, and we have to provide irrigation. In the oasis, we've seen with the last 6 years also some date productions going down because of low rainfall, and also the underground water has gone down significantly. At the genetic level, we have programs to do genetic improvement and selection. And this is one example in collaboration with ICARDA. We developed a new wheat variety called Jawahir that we've registered in 2022. It's in the process of being multiplied. It has also good resistance to disease, but very drought tolerant. In a year of drought, this crop or this variety has shown 30% more yield compared to older crops. And we have other varieties in barley also, and in bread wheat that's shown also some similar examples. I mentioned cactus is a very resilient crop. It has high value. It can be used for fruits. Fruits is highly demanded in Morocco. It's also a feed. It can be used to feed sheep and cattle. The seed can be used to make a high-value oil, cosmetic oil. However, in 2014, there's an insect, a cochineal, that appeared in Morocco and has devastated about 50,000 hectares of cactus disappeared in a lot of region. Fortunately, INRA had a collection in Agadir of about 400 varieties and species. We did a selection of these varieties. We took copies, but just by taking a cladode or cactus and planting it in the area where the cochineal appeared, and all of them died except 8 varieties or 8 ecotype. And we registered those, and we are in the process of multiplying them. And the picture on the top shows the cochineal. It looks like a white cottonish substance. And in the bottom, with the multiplication process we have initiated, and we produced up to now 10 million plants, sufficient to plant 40,000 hectares. Our objective is to plant 120 by 2030. Another important practice to deal with low rainfall and climate change is conservation agriculture. And it's well known that no-till can be a technique to preserve water in the soil, because we are not tilling the soil and we are not evaporating the water that has been there from rain. And INRA has been working on this for a while until we started this new strategy, and it was decided that Morocco should implement this technique. And we found that the gain or the improvement of yield is in average 30%, and that some years of drought, if we have side-by-side growth, it can be 100% difference in yield. There's also saving in costs for the farmers, because they don't need to go 2 or 3 times with the tractor. Another positive factor is a reduction in erosion, saving fuel, and also sequestering more carbon in the soil with this technique. So we started this in 2020. We are about 150,000 hectares we've done last year. Drought has limited the progress of this, even though it's adapted. This technique can be used with less water. If there's no rain, you won't get anything. So you have to have a minimum of water to use this technique. And some farmers didn't see that, nothing like in the last year. So we haven't progressed maybe as fast, but we keep optimistic that we will reach 1 million hectares by 2030. Another strategy that we're working on is agroforestry, and the advantage or the benefit of agroforestry in improving productivity and profitability, also improving sustainability and resilience to climate change. And 4 elements are shown that can be improved: soil fertility with agroforestry, water use efficiency, crop productivity, and carbon sequestration. These are on the qualitative side. Quantitatively, within a project that we are initiating, we are aiming to plant 500,000 hectares as an agroforestry system, plant about 50 million trees, and do that with 100,000 farmers. So those are some objectives. We are just starting this project. And then in terms of some benefits also with agroforestry, we estimated that we can gain about 30% in biomass, improve water use reserve by 30%, improve carbon sequestration on average 1 ton per hectare. This can be very variable depending on the crop, depending on the zone or area. And most importantly, for the farmers, improve the return on investment. We estimated about 6-to-1. What is important to say, agroforestry is not new, obviously, in Morocco. The oases are an agroforestry system. The mountain, there is also agroforestry that has been practiced, olive, combining that with annual crops for several generations. What we did with this project is we selected the 5 zones where farmers do not grow trees. They grow, for example, in an area called Hamna between Casablanca and Marrakesh. Basically, you wouldn't see very many trees. Farmers grow barley on barley or wheat on wheat. They don't do good rotation, and tree is not part of their equation in terms of farming. So we would like to introduce and help them plant trees and show them that, in fact, we did show that planting trees, INRA has shown, the yield can be higher, even though the area that you are growing cereals is smaller. You can have a higher yield with agroforestry, plus all the benefits that I showed you. I would finish with talking about biodiversity. I talked about the importance of water and soil, and now biodiversity. We need to maintain and conserve our resources. Morocco has very rich biodiversity of crops and animals. Some examples, some numbers in terms of species, genuses and families in plants, and also in fauna. And preservation of biodiversity is crucial for maintaining ecological balance, promoting food security, and fostering resilience in the face of environment change. I shown the example of cactus. If we didn't have that collections, we probably would not have the resistant variety that now we are multiplying. We do have a gene bank in Stad, here in Casablanca. It has about 73,000 accessions, has a capacity of 80,000 accession. We are building a new facility near Rabat. It will have a capacity of 200,000 accession. In addition to, we expect to be open this year. In addition to plants, we would like to also conserve microorganisms. I believe that the speaker this morning has shown the importance of microorganisms. We've done very little research in Morocco in microorganisms and serving and characterizing those microorganisms. We would like also to have a section on animal conservation in terms of creating a cryobank. There are several races of sheep and and cattle or bovine species native to Morocco that have been neglected, and some are disappearing. So we'd like to be able to conserve these races. As the last slide, just to conclude, climate change is real. We are living it in Morocco. The last 6 years, we've seen this drought. It's becoming more structural. The government has developed strategy. I gave some example of conservation agriculture, agroforestry, water-saving techniques, water reallocation also means to try to adapt to this change. And research has played an important role in terms of addressing some of these issues. I gave some example. There are challenges, obviously, with research. In Morocco, we experience a lot of issues with governance. We need to improve that in order to advance as fast as some of the other countries. But the government is aware of these and helping in terms of improving the research activities. Thank you.